So in this video we are going to look at 4 problems and all of them are very similar. So first let's look through the 4 questions. So the first question is from Pathfinder, which is built up your understanding, question number 13 from EMI and DC chapter. So the question is, a thin conducting disk of mass m, thickness d and radius r, where r is very greater than d, is released in a uniform horizontal magnetic field of induction B. The magnetic induction vector is in the plane of the disk as shown in the figure. Denoting acceleration due to gravity by g, find the expression for acceleration of the disk. So this is the first problem. The second problem is again from Pathfinder, from the exercise check your understanding, question number 2 from electromagnetic induction and alternating current from the same chapter. So now let's look at the question. The question is, a conducting disk of mass m and volume v is suspended with the help of a light spring of force constant k from a fixed support. Thickness of the disk is much smaller than its radius. A uniform magnetic field of induction B parallel to the plane of disk is established and the disk is pulled down slightly and released. Find period of small amplitude of oscillations of the disk. So again, this is a very similar problem. So and the third question, let's look at the third question. So this question is from some Allen test series or something, I guess. Someone posted this in my server and it's a very nice question. So yeah, let's look at it also. Two identical thin circular metal plates are at a small separation d such that d is very small compared to the dimensions of the plate. They are connected by a thin conducting rod AB of length d. Each plane has an area A. An ideal spring of stiffness K is connected to a rigid support and midpoint of rod AB as shown in the figure. Spring is made of insulating material. The system is on a smooth horizontal surface. Entire region has a uniform vertical upward magnetic field B. The disks are pulled away from the support and released. Mass of the two disks plus the system is m. Neglecting any eddy current, the time period of the oscillation is as given, and we have to find the value of alpha plus beta plus gamma, where alpha, beta and gamma are integers. So this is also a very similar problem. You should try this. And the fourth question is from some unknown source. I don't know the source for this one. So the question is, consider a rod to be placed on two parallel horizontal conducting rails in a vertical magnetic field B as shown. Now if a capacitor C is connected across the rails and the rod is started to be pulled with a force F as shown, we have to find an expression for its acceleration. So if you want to give this all 4 questions a try, you should do it now. And they are very similar, so if you are able to do one of them, you just try a bit more and probably you will be able to do all of them. So if you want to try it, you should do it now. So now the hint I want to give to you all for this question, these questions, is that both the magnetic and the external forces decides the acceleration. So it's not much of an hint, but yeah, that's all I've got. So if you want to try it again, you should do it now. So now let's look at the solutions. So let's first look at the first problem. So basically, first let's try to understand what exactly is happening over here. So initially, as there is no velocity, magnetic force is absent and the disk starts accelerating downwards. So basically, there's a mg force downwards and there's no velocity, so there's no magnetic interaction initially. So it will start accelerating downwards with an acceleration of g initially. Now, as it starts accelerating downwards, positive and negative charges in the conductor start feeling forces in opposite directions. So basically what I'm saying here is that, let's say a charge